Next topic, subsequences. Let Sn be a sequence if Nr is a sequence of positive integers such that n1 less than n2 less than n3 less than and so on. Then the sequence Snr is called a subsequence of sequence Sn. Example, if 1 minus 1, 1 minus 1 and so on is a sequence, then only once is a subsequence of given sequence and only minus 1 sequence is also another subsequence of given sequence. Next example, sequence Sn equal to 2, 4, 6, 8, 10, 12 and so on. Then 6, 12, 18, 24 and so on. This is the sequence is multipliers of 2. Next, this sequence is multipliers of 6. So 6 equal to 2 into 3. So 2 multipliers and 3 multipliers are equal. So is a subsequence of sequence Sn. Next topic, bounded sequence. First definition, upper bound of the sequence. A sequence Sn is said to be bounded above if the range of the sequence is bounded above. That is, if there exists u belongs to R such that Sn less than or equal to u for all n belongs to capital N. The real number u is called an upper bound of the sequence Sn. So condition is Sn less than or equal to u. Lower bound of the sequence. A sequence Sn is said to be bounded below if the range of the sequence is bounded below. That is, if there exists L belongs to R such that L less than or equal to Sn, L less than or equal to Sn for all n belongs to capital N. The real number L is called the lower bound of the sequence Sn. Next, bounded sequence. A sequence Sn is said to be bounded if the range of the sequence is bounded. That is, if there exists L comma U belongs to R such that L less than Sn less than or equal to U for all n belongs to capital N. Means if a sequence Sn is said to be bounded if there exist bounded above and bounded below. So then the sequence is called bounded sequence. Note point, a sequence Sn is bounded if and only if there exists k belongs to R plus such that mod Sn less than or equal to k for all n belongs to capital N. Mod Sn less than or equal to k expansion is minus k less than or equal to Sn less than or equal to k. Here minus k is the lower bound, k is the upper bound. Then Sn is the bounded sequence. Next, unbounded above, unbounded below and unbounded sequence. A sequence Sn is said to be unbounded above if the sequence is not bounded above. Next, unbounded below if the sequence is not bounded below. Next, unbounded sequence if sequence Sn is either unbounded below or unbounded above. Problems. Show that the following sequences are bounded. First one, Sn equal to k. It is a constant sequence. Next, range of the sequence means set of all elements of the sequence Sn. So here range of the sequence Sn is single term k. Here k is bounded above and k is bounded below also. So then sequence Sn is bounded. Next, Sn equal to n by n plus 1. If n belongs to capital N, that implies substitute natural numbers. So S1 1 by 2, S2 2 by 3, S3 3 by 4 and so on. So S1 value 0 0.5, 0 0.3, 0 0.7, 0 0.8 and so on. So the values in between 0 greater than to 0 and less than 1. So value is 0 less than Sn less than 1. So bounded below is 0 and bounded above is 1. Then there exists bounded below and bounded above of the given sequence. Then Sn is bounded. Next. Sn equal to minus 1 whole power n. So S1 minus 1, S2 1, S3 minus 1, so on. So range of the sequence is 1 comma minus 1. So bounded above is 1 and bounded below is minus 1. Then sequence Sn is bounded.